According to the New York City Electrical Code, the minimum wire size for crossarm wiring in a sports lighting pole is number 12 American wire gauge. Conductors rated 30 amps or less may be number 14 American wire gauge. Given that the manufacturer has supplied number 16 American wire gauge wiring, this does not meet the New York City Electrical Code requirements for crossarm wiring. The number 14 American wire gauge wiring in the pole to the crossarms is acceptable for the pole wiring. Therefore, the number 16 American wire gauge wiring to the fixtures must be replaced with number 12 American wire gauge or number 14 American wire gauge, provided it is rated 30 amps or less. It is essential that the wiring be inspected and approved by a licensed electrician to ensure complete compliance with the New York City Electrical Code. When dealing with electrical installations, adhering to the relevant codes and standards is paramount to ensure safety and prevent potential hazards. The American wire gauge, often abbreviated as AWG, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number, the smaller the wire's diameter and vice versa. This numbering system is crucial for selecting the appropriate wire size for different electrical applications, considering factors like current carrying capacity, voltage drop, and safety requirements. In the context of the New York City Electrical Code, specific regulations govern the minimum wire size for various applications, including crossarm wiring in sports lighting poles. These regulations are in place to ensure that the wiring can safely handle the electrical load without overheating or causing a fire hazard. The code mandates that the minimum wire size for crossarm wiring be number 12 American wire gauge. However, an exception is provided for conductors rated 30 amps or less, which may use number 14 American wire gauge. This exception recognizes that smaller conductors can be used safely when the current load is relatively low. Given that the manufacturer supplied number 16 American wire gauge wiring, it's crucial to understand why this does not meet the New York City Electrical Code requirements. Number 16 American wire gauge is a smaller gauge than both number 12 and number 14 American wire gauge, meaning it has a low current carrying capacity. Using a wire gauge that is too small for the intended current load can lead to several problems. Firstly, the wire can overheat, potentially melting the insulation and causing a short circuit or fire. Secondly, the voltage drop across the wire can become excessive, leading to dimming of the lights or malfunctioning of other electrical equipment. Thirdly, it violates the electrical code and could result in fines or other penalties. Since the number 14 American wire gauge wiring in the pole to the crossarms is deemed acceptable, it likely meets the code requirements for the specific application and load conditions within the pole itself. However, the crossarm wiring, which connects the pole wiring to the individual light fixtures, is subject to different requirements due to factors like exposure to the elements and the potential for higher current loads. To rectify the non-compliant number 16 American wire gauge wiring, it must be replaced with either number 12 American wire gauge or number 14 American wire gauge. The choice between these two gauges depends on the ampacity requirements of the fixtures and the specific details of the installation. If the fixtures draw 30 amps or less, number 14 American wire gauge can be used. However, if the fixtures draw more than 30 amps, number 12 American wire gauge is required. When replacing the wiring, it's essential to use conductors that are rated for the appropriate voltage and temperature conditions. The conductors should also be installed in a manner that complies with all applicable electrical codes and standards. This includes using proper connectors, securing the wiring to prevent strain, and protecting the wiring from physical damage. To ensure that the wiring is safe and compliant, it is highly recommended to have the installation inspected and approved by a licensed electrician. A qualified electrician has the knowledge and expertise to verify that the wiring meets all applicable codes and standards, and that it is installed correctly. They can also identify any potential hazards or issues that may need to be addressed. Electrical codes are not arbitrary rules. They are developed by experts to minimize the risk of electrical hazards and protect people and property. Adhering to these codes is crucial for ensuring the safety and reliability of electrical systems. Furthermore, compliance with the electrical codes is often a legal requirement. Failure to comply can result in fines, penalties, and even legal action. Therefore, it is always best to err on the side of caution and ensure that all electrical work is performed by qualified professionals and that it complies with all applicable codes and standards. In addition to the wire gauge, other factors to consider when selecting wiring for sports lighting poles include the type of insulation, the temperature rating, and the environmental conditions. The insulation should be suitable for the voltage and temperature conditions, and it should be resistant to moisture, chemicals, and other environmental factors. The temperature rating should be high enough to withstand the heat generated by the fixtures and the ambient temperature. The wiring should also be protected from physical damage, such as abrasion or impact. Proper grounding is another critical aspect of electrical safety in sports lighting poles. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing a shock hazard. The grounding system should be properly installed and maintained to ensure its effectiveness. Regular inspections and maintenance of the electrical system are essential for identifying and addressing any potential problems before they become serious. This includes checking the wiring for damage, testing the grounding system, and ensuring that all connections are tight and secure. By following these guidelines, it is possible to ensure that the sports lighting pole wiring is safe, reliable, and compliant with all applicable codes and standards. Remember, electrical work can be dangerous, and it should only be performed by qualified professionals. Always consult with a licensed electrician before undertaking any electrical project. Let's delve deeper into the specific requirements and considerations for sports lighting pole wiring in New York City. The New York City Electrical Code, like most electrical codes, is based on the National Electrical Code, or NEC. However, New York City often has local amendments and additions to the NEC to address specific conditions and concerns within the city. It is crucial to consult the most current version of the New York City Electrical Code to ensure compliance. The code provides detailed requirements for wiring methods, conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. These requirements are designed to protect people and property from electrical hazards. For sports lighting poles, the code may have specific requirements related to the environment, the type of fixtures used, and the height of the pole. For example, the code may require the use of weatherproof or waterproof wiring and enclosures to protect the wiring from the elements. It may also require the use of specific types of fixtures that are designed for outdoor use. The height of the pole can also affect the wiring requirements, as taller poles may require larger conductors to compensate for voltage drop. The concept of voltage drop is crucial in long wiring runs, especially in sports lighting poles where the distance from the power source to the fixtures can be significant. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause the lights to dim or malfunction, and it can also reduce the efficiency of the electrical system. To minimize voltage drop, it is important to use conductors that are large enough to carry the current without excessive resistance. The code provides formulas and tables for calculating voltage drop and for selecting the appropriate conductor size. In addition to voltage drop, it is also important to consider the ampacity of the conductors. Ampacity refers to the maximum current that a conductor can carry safely without overheating. The ampacity of a conductor depends on its size, its insulation type, and the ambient temperature. The code provides tables that list the ampacity of different types of conductors under various conditions. It is important to select conductors that have an ampacity that is sufficient to carry the expected current load. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overloads and short circuits. These devices will trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the wiring. The code requires that overcurrent protection devices be sized appropriately for the conductors they are protecting. The size of the overcurrent protection device should not exceed the ampacity of the conductor. Grounding is essential for providing a safe path for fault current to flow back to the source. A properly grounded system will help to prevent electric shock hazards and reduce the risk of fire. The code provides detailed requirements for grounding electrodes, grounding conductors, and bonding. It is important to follow these requirements carefully to ensure that the grounding system is effective. Regular inspections and maintenance of the electrical system are essential for identifying and addressing any potential problems. This includes checking the wiring for damage, testing the grounding system, and ensuring that all connections are tight and secure. Any damage to worn wiring should be replaced immediately. The grounding system should be tested periodically to ensure that it is still effective. All connections should be checked to ensure that they are tight and secure. In addition to the technical requirements of the electrical code, it is also important to consider the safety aspects of working with electricity. Electricity can be dangerous, and it is essential to take precautions to protect yourself from electric shock. Always energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Remember, electrical work should only be performed by qualified professionals who have the knowledge and experience to do the job safely and correctly. Adhering to the electrical code and taking appropriate safety precautions will help to ensure that the sports lighting pole wiring is safe, reliable, and compliant with all applicable regulations. Let us further clarify some important points. Firstly, regarding the conductor rating of 30 amps or less allowing for number 14 American wire gauge, this rating refers to the overcurrent protection device protecting that specific circuit, not the load. The overcurrent protection device, like a circuit breaker, must be rated at 30 amps or less to allow for the use of number 14 American wire gauge. Secondly, concerning the replacement of number 16 American wire gauge with either number 12 American wire gauge or number 14 American wire gauge, it is crucial to assess the actual load that each fixture will draw. If the fixture's load exceeds the ampacity of number 14 American wire gauge, then number 12 American wire gauge must be used. Number 14 American wire gauge is generally rated for 15 amps or 20 amps depending on the insulation type and application, while number 12 American wire gauge is generally rated for 20 amps or 25 amps. Consult the ampacity tables in the New York City electrical code for the exact ampacities based on the specific wiring conditions. Thirdly, when splicing or terminating the wiring, use connectors that are listed and labeled for the specific application. For example, use weatherproof connectors for outdoor locations and ensure that the connectors are properly sized for the conductors being used. Improper connections can lead to loose connections, overheating, and potential fire hazards. Fourthly, ensure that the wiring is adequately supported and protected from physical damage. Use cable ties, clamps, or other suitable means to secure the wiring to the pole structure. Avoid running the wiring in areas where it could be exposed to abrasion, impact, or other forms of damage. If necessary, use conduit or other protective measures to shield the wiring from physical hazards. Fifthly, when working at heights on the sports lighting pole, follow all applicable safety regulations. Use appropriate fall protection equipment, such as harnesses and lanyards, and ensure that the work area is properly barricaded to prevent access by unauthorized personnel. Be aware of overhead power lines and maintain a safe distance from them. Sixthly, after completing the wiring installation, conduct a thorough inspection to verify that all work has been performed correctly and that all connections are tight and secure. Use a multimeter to test the continuity of the wiring and to check for any shorts or ground faults. Also, verify that the grounding system is properly installed and that the grounding electrode resistance is within acceptable limits. Seventhly, before energizing the circuit, inform all relevant personnel about the work that has been performed and any potential hazards. Post warning signs as necessary. Ensure that all safety devices, such as circuit breakers and ground fault circuit interrupters, are functioning properly. Eighthly, after energizing the circuit, monitor the wiring and fixtures for any signs of overheating, arcing, or other abnormalities. If any problems are detected, de-energize the circuit immediately and investigate the cause. Do not attempt to repair any electrical equipment unless you are qualified to do so. Ninthly, maintain accurate records of all electrical work performed on the sports lighting pole, including wiring diagrams, test results, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. Tenthly, stay up to date on the latest electrical codes and standards. The electrical code is constantly evolving, and it is important to be aware of any changes that may affect your work. Attend training courses and seminars to enhance your knowledge and skills. By following these guidelines, you can help to ensure that the sports lighting pole wiring is safe, reliable, and compliant with all applicable regulations. And remember, when in doubt, always consult with a qualified electrician.